So now that you have a little bit of background in the kind of basics of chemistry, we can start to talk about how these atoms are going to work together to form molecules, and then we can start our conversation about the biologically important molecules. Okay, so let's talk about this octet rule. So when you think of octopus or octagon, right? So we're thinking about things in sets of eight. So the octet rule states that the number of electrons in the outermost valence shell of an atom, um, when there's eight of them, that's when that atom is stable. But of course, the number one rule is that there's always an exception to the rule. So explore this by looking at this carbon atom right here. So I've got our nucleus, I've labeled it C so that we remember that this is a carbon. I've got the atomic number of carbon is number 6. That means that there's 6 protons in that nucleus. And there's usually 6 neutrons, but that can vary depending on the type of isotope. And then in order to have a neutral atom, we're going to have 6 electrons. So the octet rule says, we want 8 electrons in the outermost valence shell. But the exception to the rule is that the first one gets 2 electrons. So there I have 1, 2. Now I have 4 more to go. So I'm going to go ahead and fill this up. 1, 2, 3, 4. Okay. This means that this carbon atom can, it wants, and I'm putting that in air quotes, it wants 4 more electrons to before it can be stable. So there's a number of ways that this octet rule can be fulfilled. So let's explore these covalent bonds a little bit. Here I have one oxygen atom, has an atomic number of 8, and I have 2 hydrogen atoms with an atomic number of 1. So if I have an atomic number of 1, that means I'm going to have 1 electron in my outermost valence shell. Now, remember that because this is the very first valence shell that's closest to the nucleus, that shell wants 2 electrons. Let's go ahead and fill in our oxygen. Okay, so oxygen has an atomic number of 8. That means that we're going to have a total of 8 electrons. So I'm going to put 2 in the innermost. Okay, that's filled. I'm going to go 1, 2, 3, 4. Okay, so I now have a total of 6. I'm going to put some more over here. That means that there's 6 electrons in my outermost valence shell. So oxygen wants 2 more electrons, and hydrogens only have 1, and so it wants some more. So what we can do is we can pair up these electrons. And once those are paired, then oxygen thinks it has 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is happy. Hydrogen thinks it has 1, 2. So hydrogen's happy. This hydrogen thinks it has 1, 2. So it's happy. So when we have these shared electrons in these covalent bonds, that means that our molecules are stable, and that this is an excellent way to satisfy that octet rule.